Good afternoon, Year 11. This is the final instalment for week 1, what we'd normally be looking at on Friday, and it involves comparing simple and compound interest. We're meant to be able to do this by hand and by technology. I will be trying to use both and hoping that the video of the computer works all right when we do it. Now, I think we'll go from the start. Made up a scenario out of nothing. $8,000 is invested by Beatrice, can be a name. Beatrice has invested for 5 years at 5% per annum. Find the values using simple and compound interest. So we're trying to find how much this is worth, how much this investment is going to get for Beatrice using simple and compound interest. Now, one of the stranger things, one of the newer things that you may have noticed in this section, if you've been looking at the text, is that they talk about these recurrence formulas where, the amount you've got this year is last year plus a certain amount if you're dealing with simple interest. So simple interest, the value this year is the value last year plus a fixed amount. While with compound interest, the value this year was the value last year multiplied by a compounding rate, where the rate is simply 1 plus I. So to demonstrate this today, I'm actually going to use this. You can also use the techniques that we went through in the previous lessons. They work well as well. They're cool. But let's go along this path for now. So we look at the question. Well, there's P there. That's the initial value. So you're actually given the value at time 0, whether you're using simple or compound interest, is going to be $8,000. And we need to work out under the different scenarios what it's going to be at year 1, 2, 3, 4, 5. So for simple interest, it's the previous year plus this thing they call D. And D is simply the initial value multiplied by the interest. So in this case, the initial value was 8,000. And I, which is the decimal interest rate, I is going to be 5 divided by 100 to make it a decimal. Remember, to turn a percentage into a decimal, we divide by 100. If you want to be really quick with that, we can get rid of the zeros on the top and the bottom. 5 times 80, it'll be $400. It's going up by $400 each year. Beatrice's investment will be doing that. From there, it's fairly easy. I can just add 400 for each year, and that'll tell us what the simple interest is giving us. So if I add 400 onto here, I'll get 8,400, 8,800, 9,200, 9,600, and $10,000. I trust you can do that. Now, with compound interest, it's a bit different, and it's a little more complex. With simple, it was just, add this fixed amount each time. With compound, it changes. So the value 1 year compared to last is going to be R times the value of the last year, where R is 1 plus I. So let's find out what R is first. Again, I is interest rate as a decimal. So it's going to be 1 plus 5 over 100. If you put that in your calculator, you'll get 1.05. So it's going to go up 5% each year. Surprise, given that it was 5% per annum in the first place. So, for example, if I wanted to work out the value in the first year, so the value at the first year will be 1.05 times the value at the start. So I put that in my calculator. It's going to be 1.05 times the initial value, which was 8,000. So I put that in my calculator, and it tells me, the value after 1 year is going to be 8,400. You may note that that's the same as simple interest. In the first time period, that's always the case, and I'd love to give you a very nerdy explanation of why that's the case with proofs and whatnot, but well, I'll save you today. If you want that, please let me know, and I will do that in a later lesson. But this is where it's different. If I want to know the value at the second year, it's going to be 1.05 times the value at the first year. And that's where things are going to change. So it's going to be 1.05 times 8,400, right? It's always going to be the previous year times 1.05. I put that in my calculator, I get 8,820. That's different. And I have to keep doing the same thing. It's always going to be, this rule means it's always going to be the last year times 1.05, because we know that the value of R is 1.05. So if I do that, 8,820, I get 9,261. And then if I have 9,261, again, always multiplying by 1.05, I get 9,724.05. I multiply that again by 1.05 to get the next. And yeah, it's different. Now, there's some interesting observations on that, such as, well, which one do you make more money with? Well, if you've got savings and you want to make money, then yeah, you are going to make more money by compound interest. Look at it at the end there. 10,000 compared to 10,210. You're making more money with compound interest. And the other way of looking at it is, if this was debt, if you were borrowing money and you didn't want it to get higher, well, you'd be better off with simple interest, because that's less debt than that. So these things have a lot of practical connotations. Anyway, the next thing you're going to want to do, of course, is make that into a graph. There's a couple of ways of doing that. You can do it by hand, you can do it by technology. So let's do that. We're going to do both and hope for the best. Hope that my screen shows up all right and I don't have anything too weird open in the background. My YouTube channel, that's definitely going to be a bit weird. All right, so here we go. Now, I'll try to give myself as much room as possible. If I was drawing graphs, what do? We need a good axis. And what are the values going between here? The highest is just over 10,000. So, this is going to be uncooperative, isn't it? I want it the other way around. It's like I want it back to front. Oh well, maybe I would use the ruler back to front. Here we go. So I can draw here. Now remember, time is always the independent axis. Time is always on the X. It's always along the horizontal, right? Unless you've got something very, very weird. Don't give me the exceptions. Right? So here, draw a proper scale, which means that the distance between each value is the same. I'm aiming at it being 1,000 between each value there. So we're going to go up from 0 to 2,000 to 4,000, 6,000, 8,000, 10,000 and 12,000. All right. So the x-axis is year, the y-axis is the value. So we'll call this, I don't know, Beatrice's investment, wasn't it? I probably haven't spelt that correctly, have I? Anyway, no one's watching. It's all good. So here we go. We're going to go value in dollars, because remember, Good graphs always have labels on your axes and a title. So easy marks those things usually. And along here, I'm going to do time. I only need 5 years, so I started at 0, and I might do it every 4 centimeters to. Right. Notice how we always use a ruler. I've nagged a lot of you a lot about that already. Use a ruler. Right. So here we go. 0, 1, 2, 3, 4, 5. And this can be time as measured in years. Oh, didn't do it the same colour. There'll be one person out there who goes, you know, we need to make that in the same colour. Time in years. And then, yes, at this point, I will allow you to use a little bit of approximation on it. So, at time 0, I'm going to try and put both on the same. What do I have? Green. Oh, I have green. Thanks, Rosie. You're most appreciated. All right, at time 0, there's 8,000. At time 1, 8,400. At time 2, 8,800. At time 3, 9,200. At time 4, 9,600. And at time 5, 10,000. I'm looking at the simple interest there. I'm putting the simple interest on first. Now, if I haven't stuffed that up, it should actually be in a straight line. Simple interest always forms a straight line. So, you know what? If I haven't got that perfect, I'm just going to fudge it anyway. Unfortunately, it's hurt my beautiful 8,000 over there. Anyway, so we'll do the second line. I may as well do that in, I don't know, do it in purple. All right, so this one starts at 8,000, goes up to 8,400, the same in the first time period. And then 8,820, so it's slightly higher. Then 9,261, again, slightly higher. 9,724, it's going higher again, and 10,220. So what you'll find is that with compound interest, it doesn't form a straight line. It forms eventually an exponential curve. So just note that. Simple, it always forms a straight line. While with compound, it forms an exponential line. What that means is it keeps going up by more. If you were to look at this on a really long time scale, what you would find is the simple interest would keep going straight, right, completely straight line, but the compound would go like that and eventually be quite crazy. It's an introduction to the idea of exponential functions. Technically, exponential functions are one where the speed, the rate, essentially you end up going in faster. You keep going up by more each time. I wish I could explain that clearly in simpler terms, but whenever you've got a situation where you're going up by a certain percentage, you end up getting really big numbers. And that was the issue with the recent infections. And the reason why we're doing online learning at the moment is because infections of a certain virus were increasing by between 20 and 30% per day. And you initially think, well, that's, you know, who cares? But if you look at how exponential functions work, it ends up, you know, theoretically taking the entire Australian population in a couple of months, which is a bit of an issue. Now, so look, that aside, I'm now going to quickly show you how I do this using technology. And you know what? In the real world, that's what you do. You'd use technology. You wouldn't sit around doing this by hand. So I'm going to show you my computer, and I just hope that it makes sense when you see it here. Well, sorry, as in, I hope the display's all right, because sometimes the camera looks kind of weird when it's on a computer screen. Sort of looks flashing or something, and there we go. Okay, so it's made me darker and that lighter, which is good. All right, so I've got the start of this here, ladies and gentlemen, and it's a similar table to what we had on the board just then. So we've started off at 8,000 for both simple and compound interest, and we want to see what it does over the first 5 years. So back there on the board, we worked out in the simple interest situation that it was just increasing by 400 each year, right? And you worked out that 400 by the initial value multiplied by 0.05. That's a formula that does the same. That says, I want the value here to be the value before me plus 8,000 times the interest rate. If you evaluate that, it's 400. It's that exact 400 that it was increasing by each time. Why I did the formula that way, and yes, you do need to remember that that little asterisk means multiplied by in Excel. What we can then do is copy that over here. Oh, I used Control C for copy, and I'm going to use Control V for paste. And guess what? There it is. First 5 years. Compound interest. As discussed, the compound interest is always the previous value times R. R is the compounding rate. R is simply 1 plus the interest rate as a decimal. And so this formula here, that's what it does. It says, I'm going to be the last cell times 1 plus the interest rate as a decimal. If you convert 5% to a decimal, divide by 100, you get 0.05. So there, it's done. It's always going to be the previous value times, well, 1.15. So if I get this one here, again, Control C, Control V, I get all the values that we just had over there on the board, except much, much faster. Now I know what you're thinking. Sir, I want to have a lot more fun with this. So you know what we're going to do? We're going to just extend this out. There we go. We're going to make it the first 40 years, not just the first 5 years, because all I need to do is copy this formula, and that's it. I'll have what this is worth for the next 40 years. Uh-oh. That's because the columns aren't wide enough, guys. Don't get too excited. Here we go. If I make that wider, there we go. See, I just dragged that across and it fixed that all up. Now, if I wanted to do a graph here with this in a technology, a lot easier. So all I've got to do is highlight it, go Insert. So the Insert menu up the top, we're going to go a line graph, and it didn't cooperate. That's not what we want to hear, is it? Why didn't it cooperate? Let's try again. Insert, line. Okay. That doesn't really explain it either, does it? Insert. Oh no, it's actually all right there. The problem is that the simple and the compound there are not showing properly. And the other issue is that it's not showing the axis properly. So the axis there should be those values. Excel is not always the most cooperative thing in the world, is it? See, that's correct. What we've got then there is we now have the year values there, 0, 1, 2, 3, 4, 5, and it's hard to see because the grey line is on top of the orange line, but the compound interest there is gradually becoming slightly above the simple interest. you get more value here if you look on a larger scale. So if we all of a sudden, select data and change this a bit, I'll just delete it. How about that? But if you highlight it over 40 years rather than 5 years, and we go insert, we go back to our line graph, check that out. Again, it's doing something really silly with the x-axis labels on the bottom here. It's pretty clear that year should be the x-axis here. I'm not sure what Excel's problem is. Sometimes Excel tries to be more intelligent than it is, and it just stuffs things up. But if you look at this over the long term, and this is what's really, really interesting here. So simple interest compared to compound interest at 5%, initially you go, oh, they're much the same, who cares? But if you look at it over 40 years, look at that towards the end there. Look how far above the compound interest is over simple interest. That's massive. It's more than twice as much. You get more than twice as much money over 40 years if you're using compound interest as if you're using simple interest. The other things you should have in here, of course, you should be looking at me going, sir, you don't have all the stuff in there you should. I need, there we go, add chart element, axis titles. So we can add axis titles on the bottom and the side. And yeah, you'd label them as we had on our hand-drawn graph. So that should be value. That should be time in years. And up the top here, I don't know, it's Beatrice's investment. I really stuffed that up then. Investment. So I'll do this from the side. There we go. Isn't that an absolutely beautiful graph? So, yeah, short story is that if you were investing for a long time, you're going to get a lot more money using compound interest than you would simple interest. I think that's going to do for the lesson today. Make sure to have a go at the questions. If you've got any issues, you know where I am, or maybe you don't. Thank you. Bye.